This is Section 9 of Unit 4, Accident Investigation Data. Our quote is, "It takes 8,460 bolts to assemble an automobile and one nut to scatter it all over the road. Author unknown." I think it's pretty self-explanatory what they're saying here. The objectives of this lesson are to determine the minimum skid speed using the skid mark formula, and to determine the minimum skid speed using the yaw mark formula. Here are some key terms that we need to understand the meaning of. Accident reconstructionist. This is an individual having the knowledge necessary to understand the circumstances surrounding an accident. Skid mark. This is a mark that a tire leaves on the road when in lock mode. In other words, you slam on the brakes, the wheels stop turning, and they leave a skid mark on the road. Shadow skid mark. This is a light skid mark made when the driver first applies brakes, okay? When he first applies brakes, the skid mark is going to be lighter and it's going to get darker and darker as it goes along. Anti-lock braking system. This is a system on cars designed to not allow wheels to continuously lock. It locks them, releases, locks them, releases, locks them, releases, and that affects what the skid mark looks like. The yaw mark. This is a curved skid mark made when cars slip sideways while in the same time continuing in a forward motion. So this would be a curved skid mark, basically, instead of a straight skid mark. The skid speed formula. This is a formula to calculate the speed, knowing the skid distance, drag factor, and braking efficiency. The drag factor is the number that represents the amount of friction that the road surface contributes. The braking efficiency is the decimal indicating the effectiveness of the brakes. 100%, or as a decimal 1, would be perfect brakes, perfect braking efficiency. Skid distance is the length of the skid marks. So, in thinking about this, in terms of what you can determine after an accident, is what data might a car leave behind at the scene of an accident? What information might skid marks give an accident reconstructionist? Well, probably the most obvious is skid marks, as you can see in the picture above. They're usually straight. If you have an automatic braking system, ABS, then they would be dashed, okay? They wouldn't be a continuous line. Yaw marks are curved skid marks. So the above picture shows straight skid marks. If they're curved, they're considered to be yaw skid marks. Now, what exactly is the skid speed formula? The skid speed formula is simply S is equal to the square root of 30 dfn. Now, S is the speed of the car when entering the skid, okay? D is the skid distance, okay, the measurement of the skid mark. F is the drag factor. And if we look at this table below, we see different drag factors depending on what the surface of the road is, whether it's ice, snow, gravel, asphalt, or cement. You'll notice cement has the highest drag factor, okay, whereas ice would have the lowest. Now, drag factor can be measured at the scene by using a device which is pulled basically to measure the drag factor, okay? It's a heavy device and you pull it along. If you know the weight of the device and the force, the minimum force required to slide it along the surface of the road, that can determine your drag factor. And lastly, N is the braking efficiency. Now, unfortunately, this can only be done by a mechanic, okay? He has to determine the braking force, okay, that the brakes apply. And then you have to also consider the weight of the car, and that'll determine your braking efficiency. And this is always given as a decimal, okay? Braking efficiency could be like 80%, but in the calculation you use 0.8 rather than 80%. All right, in terms of what exactly is the skid distance, it's a function of the number and lengths of the skid marks. If you have 4 skid marks, of equal length or two skid marks of equal length. If all the skid marks are of equal length, then you use that length, okay? If you have different lengths or less than 4 skid marks, okay, then you use the average. You add them up and divide by the number of skid marks. And then if you only have 1 skid mark, you use that length, obviously. All right? Now, as I said, braking efficiency is a measure of the front and rear brakes. The braking force is something that only can be determined by a mechanic, okay? It's the decimal equivalent of a percent. Okay, no brakes, okay? You put the brakes, they just don't stop. That would be 0%. Excellent brakes would be considered 100%. But you have to use the decimal equivalent of these in the formula. So let's look at an example. A car is traveling on an asphalt road with a drag factor of 0.78. The speed limit on this portion of road is 35 miles an hour. The driver just had his car in the shop and his mechanic informed him that the brakes were operating at 100% efficiency. The driver must make an emergency stop. When he sees an obstruction in the road ahead of him, his car leaves 4 distinct skid marks, each 80 feet in length. What is the minimum speed of the car was traveling when it entered the skid? Round your answer to the nearest tenth. And then lastly, was the driver exceeding the speed limit when entering the skid? All right, so we know the formula is S is equal to the square root of 30 dFn. We know the drag factor, which is little f is equal to 0.78. We know the braking efficiency is 100%, so therefore n is equal to 1. And we know the distance of the skid mark is 80 feet, so therefore d is equal to 80. I plug all of these in, and I come out with approximately 43.3 miles per hour that he was traveling when he entered the skid. So the last question, of course, is, was he exceeding the speed limit? Well, yes, he was, because the driver was exceeding the speed limit. The speed limit was 35 miles an hour, and he was going 43 miles an hour when he entered the skid. All right, let's look at another example. Melissa was traveling at 50 miles per hour on a concrete road, okay? There we know her speed, and we know it's a concrete road with a drag factor of 1.2. Her brakes were working at 90% efficiency. To the nearest tenth of a foot, what would you expect the average length of the skid marks to be if she applied her brakes in order to come to an immediate stop? Now, this would be important if you wanted to see, would she hit something if it was a certain distance away? So let's see. All right, again, we're going to use the formula S is equal to the square root of 30 dFn. We are going to solve for D. In other words, we have to take and square both sides and then divide by 30 Fn, or we come out with the formula for distance of the skid mark is equal to S squared over 30 Fn. All right, so what is S? S we said was 50 miles an hour, so that's what we put right here. 30. Now, what's the drag factor? The drag factor is 1.2, so that's what goes right here. And then braking efficiency was 90%, so I put 0.9 here. I put this all in my calculator, and I come out with the skid distance of 77.2 feet. So if she was 100 feet away when she applied the brakes, she could stop in time. But if she was only 50 feet away when she applied her brakes, she would hit whatever that obstruction might be. So now let's discuss yaw marks. As you can see in the picture, this is a typical yaw mark. Notice it's curved. It is not straight. Well, in order to calculate speed for when you have a yaw mark skid, the formula is equal to S is equal to the square root of 15 FR, where F is the drag factor, but R is the radius of the yaw mark, okay? So again, S is the minimum speed, F is the drag factor, R is the radius. Okay, how do we take and figure out what the radius is? All right, so we have a certain yaw mark, okay? And you can think of this as part of a circle. And you're going to connect from the start of that yaw mark a straight line to the other end of the yaw mark, okay? And that's a chord. That's what we refer to as C. The middle of that chord, we take and measure a perpendicular distance, and that's what we call M, all right? And we're looking for R, which is right here. So our formula is the radius, or R, is equal to the length of the chord, C, squared, divided by 8 times M. M is the distance from the chord to the yaw mark at the midpoint, plus that same value M over 2, okay? This will give us the radius. Once we know the radius and the drag factor, we can plug into the formula to get the speed. All right, here's another example. An accident reconstructionist took measurements from yaw marks left at a scene using a 43-foot length cord. Okay, that was the length of the cord. That's C. She determined that the middle ordinate, that's where M is, measured approximately 4 feet. The drag factor of the road surface was determined to be 0.8. Determine the radius of the curved yaw mark to the nearest tenth of a foot, and then determine the minimum speed that the car was going when the skid occurred to the nearest tenth. All right, the first thing we're going to do is calculate the radius, and we're going to use this formula here that we just talked about, the C squared over 8M plus M over 2. We know C is 43 feet. We know M is 4 feet, okay? So therefore, the radius is equal to 43 squared over 8 times 4 plus 4 over 2, or approximately 59.8 feet. Now, that's the radius. That's not the skid mark length, now remember. That's the radius. Okay, now we go on and see if we can figure out what the speed is from our speed formula. All right, so now let's figure out the speed, okay? We know that the drag factor was 0.8. We know that the radius distance was 59.8. Okay, and we're going to plug that in, like I said in the previous slide, into the formula S is equal to the square root of 15 FR. So I multiply 15 times 0.8 times 59.8, take the square root of it, and I come out with that her speed was 26.8 miles per hour when the yaw marks were created, okay? Now, hopefully this has explained a little bit how accident reconstructionists can use math to know a little bit more about the accident. Obviously, they're not present for the accident. They're only there for the aftermath. So they need to find out, well, how fast was the car going and some other things. And these are formulas that can be used based on the data left on the road of skid marks and the like, how fast the car was going, and other factors that relate to this accident.